Hello, welcome to the supplementary topic in lecture 3, that is implementing a handwritten digit recognizer. So let us recall what is handwritten digit recognizer a problem. Here the task is to take an image and recognize which digit is there in the image. It could be any digit from 0 to 9. So this is a multi-class classification problem. Okay. So the performance measure is the accuracy, percentage of the correct classifications. And the experience is a data set. You should have the images of the handwritten as well as its associated output, that is 0 to 9. If all the data is available, then we consider all the data is available for learning, we consider it as a batch. Okay, so let us see how it can be implemented in Python by considering some different design choices. Okay. For implementing in Python, here we are implementing, or here we are using a Google Colab for writing this code in Python, and we are using a scikit or sklearn library which contains modules and functions for writing machine learning applications. So the first step is we import all the modules and libraries functions which are required for our implementation. And typically this Colab has two different kinds of cells, a text cell and a code cell. Code cell is the part where we are writing code, and text cell is the part where we are writing description of the code. So in the left corner we have a run cell. So if we run this part of the code will be executed. If there are no issues, then this gives a green symbol saying that it is completed. So once it is completed, the next step is we have to collect the data. So here we are using as it is a standard problem, we have a benchmark data set called MNIST data set is available. So they collected images of size 28 by 28. That means each image containing 784 pixels, and every pixel value from 0 to 255, a grayscale image. 0 is representing black and 255 representing complete white. And 70,000 such images are there, and it covers wide variety of different handwritings. Okay, so as it is a benchmark in a sense that if the model is working well on this data set, it is expected to work even on real world data. Okay. So sklearn, now how to download this MNIST data set? Now sklearn provides library functions for downloading this. So it has a function called fetch openml. From fetch openml, we can download this MNIST data set, and this function is going to return two arrays. The input X and the associated output in Y. Okay, and we can see, I think if we run this one, you can see that so here we get an output saying that MNIST got loaded successfully, and the data set is of size 70,000 by 784. That means each image having 784 pixels, and the output for each image, its associated output is there. Okay. So the number of features is the number of pixels here, 784. The number of classes is 10, that is 0 to 9. And we are also displaying one sample image. Randomly we are picking one image and then displaying. And here we are displaying as a 50 by 50 by interpolation. So the data is there. Now we have to build a machine learning model which can learn from this data. Okay. So as we know that one of the goals of the machine learning is to generalize. How well it works on a new or unsigned data is important. So that is the reason what we do is we divide the data into two parts: training data and testing data. We use training data to build the model, testing data to test the model. So based on how well it's performing on a test data, we can say that how well it can generalize. Okay, so the standard way of dividing the given data into test and a training is 80% of the data we use for a training and 20% of the data we use for a testing. So here we have a library function called a train test split, where we will be giving the test size as 0.2. That means 20% of the data will go into test. Okay, so when we run it, so 56,000 images we use for training and 14,000 for testing. Okay, so next is the next design choice we have is how to represent our target function. We know the target function. Target function is which takes an image, that means that 784 pixels, and it should give output 0 to 9. So the representation of the target function, we are choosing here a multi-layer neural network. So this neural network has 3 layers. In the input layer, we have something which should take the 28 by 28 image, that means 784 different values. So an input layer with 784 neurons. Hidden layer, we had chosen 100 neurons. Output layer, 10 neurons. Okay, that means it is 784 cross 100 cross 10, the neural network. Okay, and so we have in scikit library, we have MLP classifier, that is multi-layer classifier, and we have specified hidden layer size, and we have something called an activation function. Regarding this activation function and all, we will be discussing in detail in the neural network topic. For now, try to understand that there is a representation that we have chosen, that is neural network. Next, we have to train this neural network, and for that we are using a function called model.fit. Okay, and the algorithm that any multi-layer neural network uses backpropagation algorithm. So here the choice of representation is neural network, and the choice of learning algorithm is a backpropagation algorithm. And for fine-tuning the parameters, we have used this Adam. Okay, and if we run this, so in iteration 1 we have the loss is 0.45 and the loss is decreased in every iteration. Actually it uses a cross entropy as a loss function. So once you have this, so it is running. So once it finishes, it will show how much time that it has taken and what is the neural network architecture that we had shown. So once it is completed, we can test it by running on test dataset. For that, we are going to use predict function. So predict function is going to take the two-dimensional array containing the inputs. Okay, so those inputs are 784. Each row containing 784 values. So here, when we use this model, we can specify how many iterations that it should run, what is the maximum number of iterations that it should run. We should also specify what is the tolerance. What is the tolerance? So if you observe, we have considered the tolerance as 0.001 for 10 consecutive iterations. If it is not changing by this much value, it will stop. Okay, and it has taken 119.26 seconds for training. Once it is completed, we can run it. Okay, now we are running this on those 14,000 images, and we got a accuracy as 97.5. 97.5%. Okay, so and we can also run it on a sample image. Here we have a sample image. Randomly we are picking one sample image from the test data. When we run it. So we have the true label that is from a data set and what is predicted. So here we are using this model.predict to predict the label, and both are matching in this case. As the accuracy is 97.5, it is like for every 100 images there might be 2 images where it might give a wrong label. Okay, you can see here because the true label is 0, but it has predicted 2. Okay, so for this image it has failed. Okay, so one more time. You see here for true and predicted is also 5. Same thing. And true is 7 and predicted is 7. So this is how one can implement by considering design choices, different design choices. Okay. And this Colab implementation, I will also add in the details of. Will also add in the details section. This link I will add in the details section. You can see here play with it and you can test it. Okay, so by clicking that link you can also get your version of this. You can also experiment it. Thank you.